Alright guys, good morning. So today I'm just going to go ahead and show you guys how to solve Rex. Alright, I'm going to be focusing mostly on just linear functions on this video, mostly x being only on one side as well. So as you can see, I have 6 problems here. These are like the basic problems. Uh, and honestly, all you have to worry about is you just need to do inverse operations. That's pretty much it. Okay. Yes, we have a calculator, but I'm gonna go ahead and show you guys how, in reality, at least for these problems, you really don't need it. All right, so here's what's up. So I guess the first thing you want to do is see where the equal sign is at, and I would highly recommend you draw this little line here down the bottom because there's this thing that we say in algebra or in any math class that whatever you do to one side, you must do it to the other. And I've seen so many kids start off and like, oh, I'm gonna move this, but they end up moving it to the same spot. So again, it's important you move it to the other side of the equal sign. That's what the line is for mostly, just so you could visualize it. Anyways, so when we're solving for a variable, the whole goal is to isolate it. In this case, on number 1, I have x plus 7 is equal to 10. Now when we isolate the variable, we're going to do so by doing the inverse operations. So right now this is a plus 7. So think about what is inverse of addition. Well, it is subtraction. And by inverse, guys, I know a lot of you guys might know it as the opposite. So again, what's the opposite of addition? No, it's subtraction. Now the correct term is inverse though. But so again, we must take away 7 from both sides. So positive 7 minus 7 go away, and 10 minus 7 is 3. The only thing left on this side is just the x. We bring down the equal sign, and so our answer is x must be 3. Do the same thing for number 2. There's a minus 8. The inverse of subtraction is addition, so plus 8 plus 8. We're left with the x. 5 plus 8 is 13. You can always go back and check your work by just plugging it in and ask yourself, is 13 minus 8 equal to 5? And yes, it is. Alright, so number 3, and sorry about, I was going like this and then, sorry about that. We'll go to number 3. Whenever you have a number that's before the variable, like right before it, there's no plus or minus or anything in between, it is implied that we are multiplying. And so, the inverse of multiplication is division. Now, many people do it differently. Some people like to literally put the little divide symbol. Personally, I just make it look like a fraction. And again, we're dividing by whatever's before the x. So I'm going to divide by 4, and whatever you do to one side, you must do it to the other. Now, 4 divided by 4, that's 1. So this becomes 1x. But it's the same thing as just x. 20 divided by 4 is 5. And again, we are done. Okay. Again, we're done. Yeah. So again, it's just x is equal to 5. Okay. It's bugging me that there's the line on the equal sign as well. But x is equal to 3, right? X was 13. X is equal to 5. All right. Number 4. Whenever there's a little line underneath the like this, we're implying division. So right now there's division taking place, and the inverse of division is multiplication. So we have to multiply both sides by 4. Multiply by 4, multiply by 4. 4 divided by 4, again, they pretty much cancel. They become 1, and I'm just left with x. And 10 times 4 is 40. So x is 40. So those are the basics, okay? Let's look at numbers problems 5 and 6. So on 5x6, again, same thing. You want to isolate the variable. So one way we could do it is just move the 5 over. We bring down this negative x, right? 12 minus 5 is 7. but I don't want to have a negative x, so we could divide by a negative 1. And so when we divide by a negative 1, basically we just change the sign. So x is negative 7. Again, the reason it becomes positive is a negative, or a negative becomes positive. The reason it becomes negative is a positive divided by a negative is negative. Another way to do this so that you don't have to divide by negative 1 is if you just move the x to the other side. Nowhere does it state that x has to be on the left side of the equation. So this becomes 3 is equal to 9 plus x. And again, you want to leave x by itself, so minus 9 minus 9. Three minus 9 is negative 6. And so x is negative 6. And again, another way to check is by plugging it in. Is 3 minus negative 6 equal to 9? Yes, it is. All right, let's look at what happens when you have distribution, when you have parentheses. It's pretty much the same thing, and I'm sure you guys remember all you have to do is just distribute. You guys might know it so many different ways, rainbow. I don't know how else you guys could know it, but its name is distribution. So we're going to get this 2 and we're going to multiply it by x, so this becomes just 2x. We're going to get this 4, right? It's going to be 2 times 4, so 8. And now this problem becomes like one of those problems before. So we just have to move the 8 over by subtraction. So this becomes 2x is equal to 10. And then we just divide by 2. And so x is 5. And the first 4 problems are essential for everything else. Let's go ahead and look at a few more, and then that's it. So there'll be times when you have to combine like terms, and when we combine like terms, all it means is look at the terms, and if they have the same variable, or in this case, if they don't have a variable, you can combine them. And again, if they're on the same side. So we have a 4, a 2x, and a negative 4x. So again, the like terms are the x's, so we can combine them. So this becomes 4, positive 2 minus 4, that's negative 2. So again, notice how we combined them and it became a minus 2x. Again, at this point, just repeat the process from earlier, minus 4 minus 4. So this becomes negative 2x must be equal to 14. But I must divide by a negative 2 to leave x by itself. And that's it. And again, you can always check your work by plugging it in. Well, 4 plus 2 times negative 7 minus 4 times negative 7 give me 18. And it does, okay? Number 9. Again, it's just sometimes they'll combine the problem. So this is just one of those where you have to distribute first and then combine. Here it's obvious we're going to distribute the 3. So this becomes 3x plus 12. Here, there's no actual number in front, but there's just a negative. We could pretend like there was a negative 1 in there. You know, when you multiply by 1, you don't do nothing in reality. But this is a negative, right? So we're just distributing that negative. So that becomes a negative x, and that becomes a negative 9. And again, we're going to go ahead and combine our like terms. We have a 3x and we have a minus x. So together, those become 2x. We have a positive 12 and a negative 9. Together, they become a positive 3. And again, here's where it becomes simpler now. Minus 3, 2x must be equal to 97, and so we must divide. And there will be times when you get decimals or fractions. Like for example here, if you have one of those fancier calculators, put two of them. It would tell you that it's just 97 over 2. If not, odds are it'll give it to you in decimal form already, which in this case is just 48.5. There's nothing wrong with decimals. If your answer is right, it's right. And again, the best way to check is to go back and substitute. When you substitute back in, you should get 100, and that's how you know that you did it correctly.